Well, here we go on the last little bit of horizontal asymptotes. I just want to practice a little bit more. We've seen the practice of this type on the first and second question, so I'll go kind of fast here. We need to look at the end behavior. So the horizontal asymptote is an equation, y equals something. And we can find that by looking at y from the dominant division. I need the x over x squared, so that is 1 over x. Now remember, x is going to infinity, it's going big. Now if we're dividing by a big number, that means the answer is going to be small. So in the final analysis then, it's going down to 0. That is the horizontal asymptote equation. Let's do it again. We're looking for a horizontal asymptote, and it's going to be a y equals equation. So we're going to take this function and study as x goes big, what does y do? Well, y is going to be determined by the leaders. There's the leader, and there's the leader of the denominator. Oh wait, this one's balanced. The one before was bottom heavy, but these two are balanced. The x's are going to cancel out, so technically we're going to have 6 over 2, which is 3. So the end behavior of the y's as x goes really big is going to come down to y equals 3. Now, we haven't formally done any examples like these graphs, but casually we have. We're looking at the graphs, and we're going to kind of look at inspect a graph and kind of estimate the horizontal asymptote. And so we're looking at these tails. What is their end behavior? And it seems like they're coming down or collapsing on this x-axis. So in that case, we'd say the horizontal asymptote is y equals 0. On this one, we're looking at these tails, and what are they approaching? Well, they seem to be settling down right here. And that is telling us there's a horizontal asymptote y equals -4. Okay, I'm going to set a timer here for myself so that I can not take these lessons too long, because I've been using too much time on these things. So hang on just a second. Should have done this already. All right, let's go to the next slide. We're ready to finish this topic now. Let's just switch over to vertical asymptotes. So vertical asymptotes, they come up whenever the denominator goes to 0. So it's all about the bottom. If we're looking at vertical asymptotes, it's all about what the bottom is talking about. So if we concentrate on the bottom here, x plus 2 cannot be 0, which means x cannot be -2. Something's going to happen because this is not allowed in the domain. So -2 is a critical x number where the graph is broken. Let's see what happens when we graph. Well, sure enough, right here, it is broken. I have two different branches, and they're separated at this x equals -2. So at the number x equals -2, there is no output at all. It's like an empty spot in the graph. It's just broken into two branches there. Here's another one. Let's look at the bottom again. That's the denominator. And we want x squared plus x minus 2. That cannot be 0. Because if the bottom is 0, we're dividing by 0, and that's undefined. But if we factor this, Still don't want it to be 0. This would be x plus 2, x minus 1. And we would find two solutions to this, which would technically be telling us x cannot be negative 2 and x cannot be 1. These are two bad x's for that function. Because if I put 1 in here, I'm going to divide by 0, and that will cause the function to fail. And likewise, putting negative 2 in there, I'll be dividing by 0 and cause the function to fail. You might plug those in and actually convince yourself to see what's happening there. So pause the computer and do that just to convince yourself how the function gets broken at that point. So if we graph, we're going to see something. And we see, oh, there's a broken part in the graph right here. And that's at x equals negative 2. There's another part in the graph that is broken here. And that's at x equals 1. So the graph is broken 2 places and makes 3 different branches on that. So we're going to begin a discussion now about how these vertical asymptotes come about, how to find them, and some of their other characteristics, because at each vertical asymptote we have a tail. And we need to talk about this tail behavior too at these vertical asymptotes. So that's where we're going now. We're going to talk about these vertical asymptote tails. Well, no, let's just formalize our discussion about vertical asymptotes a little bit more by practicing an example here. So, what do vertical asymptotes come down to? They come down to domain restrictions, broken places in the graph, and the domain restrictions come from the bottom. So one strategy is always to factor the top and the bottom, because other stuff comes out of the top when we factor. Let's see, we're going to need a plus 5 minus 3. Now, what are the domain restrictions here? Well, it comes from the bottom. Vertical asymptotes. They come from the bottom. So all we have to do is worry about the bottom. X plus 5 cannot be 0. X minus 3 cannot be 0. So x cannot be negative 5 for this graph, or x cannot be 3 for this graph. And when we graph it, we're going to see those broken places. One right there at negative 5. Another one of these broken places right there when x equals 3. Now, the graph of the function is the black line. The purple line is the asymptote. It is not part of the graph. But we do identify these asymptotes as equations. Now, vertical line equations. Vertical asymptotes are equations in x. That's the equation of a vertical line. X equals a number. So one of them is x equals negative 5. That's one of the vertical asymptote line equations. And we have another one at x equals 3. These are two vertical asymptote line equations.